In the first practice problem 1.1, we were asked to calculate the amount of charge represented by 6.667 trillion protons. And we know that the charge of one proton is 1.602 into 10 power of minus 19 coulombs. So, the charge of 6.667 billion protons is one charge of proton, the charge of one proton multiplied by that many number of protons, which are 6.667 into the 10 power of 9 multiplied by 1.602 into 10 power of minus 19, and which implies the answer is 1.60805 into 10 to the power of minus 9 coulombs. Coulombs is the unit of charge. They are measured in charge, coulombs. The charges are measured in coulombs. And example 1.2, we were given an equation, a charge equation, which varies with respect to time, and the total charge entering the terminal is given by Q is equal to 5t sine 4t millicoulombs. We were asked to calculate the current entering at t is equal to 0.5 seconds. We know that I is equal to dq by dt, which means I is equal to q by t, and we were given a function, so we are using the equation I is equal to dq by dt, and we see that there are two terms of t which we have in the given equation. So using UV formula, d of uv is equal to uv dash plus vu dash, which implies keeping phi t as constant, let's differentiate sine 4 pi t. On differentiating sine function, we get a cos function, phi t into cos of 4 pi t, and on differentiating the inner function of the sine function, we get 4 pi. So phi t into 4 pi into cos 4 pi t plus, and keeping sine 4 pi t as constant, we differentiate 5t, which leads to phi sine 4 pi t plus 20 pi t cos 4 pi t amperes. Current is measured in amperes, and at time 0.5 seconds, we see the current is 20 pi t, which is 20 into pi into 0.5, okay, and multiplied by cos 4 pi into 0.5 plus 5 sine 4 pi into 0.5, which is 5 sine 2 pi. We know the value of sine 2 pi or sine n pi is always 0. So 0 plus 10 pi into cos 2 pi, which is 10 pi milliamps. So that gives rise to 31.42 milliamps. So here's the solution. Take a look at it, guys. Thank you so much. Let's wait for the next video. I'll see you guys there. Bye bye.